In this video, we're going to talk about the reaction of a strong acid with a strong base. Now let's take HBr, a strong acid, you should recognize them, plus any 1A or 2A metal salt, NaOH. And if they're strong, they react 100%, so we put a one-way arrow. And what happens with this is there's just an exchange of the H with the sodium. The H plus takes the place of the sodium, and the sodium takes the place of the H plus. And so what you get is NaBr plus water. And you're always going to get the salt plus water for a strong acid, strong base reaction. This first reaction is called the molecular reaction. So I'll write that in here in blue. That's one way of looking at it. The other way of looking at it is the total ionic. And so I'll write that. We'll do the total ionic next. Same thing. Now remember what HBr does in water. This is going to be HBr reacts with water to give us H3O plus Br minus. And sodium hydroxide dissociates in water to give us Na plus OH minus. That's how it actually is in water. That's how it exists. This gives us sodium plus Br minus. That's what we get out of here. And here we get water is itself. Now, we're missing an extra water from here because if you remember, HBr plus water gave us H3O plus Br minus. So we get an extra H2O out of this. And so we get 2 H2O. So that is coming from this OH grabbing one of these H's. Okay? This is called the total ionic. Another way of writing it, and it's somewhat easier, is to write H plus Br minus from the HBr and sodium plus OH minus from the sodium hydroxide gives us Na plus Br minus plus H2O. Either way is acceptable. You'll probably find this method down here easier. So that's the total ionic. The final way of writing it is the net ionic, what actually happened. So let's look at the net ionic. And in the net ionic, what we're going to do is cancel out the spectator species. So I've rewritten that, and now I'm going to cancel or cross out the things that are on both sides. So there's a bromide on both sides. There's a sodium on both sides. And so my net reaction becomes H plus OH minus to yield water. And so the net ionic is H plus OH minus yields water. Or if you did it this way, H3O plus OH minus yields 2 waters. And you should recognize that as the backwards reaction of the autoionization. So these ions here in blue up here are called spectator ions because they're in the solution, but they're not reacting in any way. Okay? And that's a spectator ion for that, one of your definitions. That's it. Let's do another one. I'll do a slightly more complicated one. Let's do calcium hydroxide plus, there's 2 of those, HNO3. What you notice right away is there's 2 of these OHs, so you're going to have 2 H pluses, which means I need to put a 2 here. So pay attention to that portion of it here. That's all that's happening is those H's combining. And so I get calcium nitrate, and there's 2 of them. Nitrate is -1. Remember that. Calcium's +2. And I get 2 waters. That's the molecular. The total ionic would be breaking them up into their pieces. Calcium +2 plus 2 OH minuses plus 2 H plus 2 NO3 minuses yields calcium +2 plus 2 NO3 minuses plus 2 H2O. And if I want to do the net ionic, I just cancel my spectator species. So the calcium cancels on both sides, the nitrates cancel on both sides, and I end up with 2 OH minus plus 2H plus yields 2 water. And so my net ionic reaction is 2OH minus plus 2H plus. The easier way to write it yields 2H2O. That's it. There's lots of these that you can do. Practice them.